Logarithmic and exponential equations, solve. So in this section, we're going to talk about solving equations in various ways. And again, we can use any of the tools we learned previously. The exponential properties, log equivalencies that we dealt with the y equals log base of b of x and its equivalent exponential form. We can talk about that. We can talk about the product rule of logs. We can talk about the quotient rule of logs, the power rule of logs, or the inverse property that we have between logs and exponentials. So any of those could be used in any of these problems. So that's what we're getting into now. So we have to determine which one we're going to use and when. So this is where the difficulty lies. So this first problem, number A here, says 4 to the negative 3v minus 2 equals 4 to the negative v. So when I see this problem, right away I see that the bases are already the same. So if this equation is going to be true, since the bases are the same and those are constants, that tells me here that the exponents will have to be equal. So that tells me then that negative 3v minus 2 has to equal negative v if this equation is to be true. So then to solve this, I can move the 3 over. So then this is going to be 2v equals negative 2. Divide by 2 there, and I'm going to get v equals negative 1. So negative 1 is my answer for this first equation. So that one's very nice, very set up for us already, so there's not much to do as far as using our new tools and properties of logs and exponentials. Okay, let's move on to number B now. So this one's going to take a little more time in order to get it to look like the problem A here. But we're going to do it in a similar way in the end. So take a look at this one here. So we have 2 to the negative 3n. Now, can I get this in terms of a base 2? And I can. And the reason why I'm trying to do that is because I see base 2's everywhere in the equation except there. So automatically I think of trying to get that in terms of a base 2 as well. And I can. This is actually going to be 2 to the negative 2. And this is times here, and this is 2 and 2 to the n plus 2. Okay, now what I have here is a product. And when I have multiplication, I add my exponents. So this actually comes together, and this is using those properties from the exponents. So this is going to be 2 to the 3n minus 2, and that's going to equal 2 to the n plus 2. So now that I have the same bases, and when I mean the same base is a single base on each side, it has to be in this form for me to get it to where I need it to be, then I can say negative 3n minus 2 has to equal n plus 2. And then from here, I just solve the equation. So I can add 3n minus 2, add 3n and minus 2. So those go to 0. I get 4n on this side, and I get negative 4 over here. So then when I divide by 4, my n equals negative 1. So there's my answer for this one here. So there's two problems that we've done just using the principles of exponents. So let's look at this next one here. So number C here is a little different, and I think I'll do this one in the next video.